part of your homework tonight is going to be to sketch angles in standard position. We always start like at 0, and then we measure to wherever we need to go. We always put what direction we're going in. If we're measuring a positive angle, we go counterclockwise. If we're measuring a negative angle, we go clockwise. And we usually either label that with a Greek letter or another letter, or if they tell you like 4 pi-thirds, you can actually just put 4 pi-thirds there when you're doing that. And we're going to do some of those in a minute. I skipped the next slide. We'll come back to it in a minute. This is where I'm going to kind of just rewrite this. This is where it gets a little weird because it's weird to think about angles bigger than 360 degrees or bigger than 2 pi. But yesterday, I believe we drew in a 60-degree angle, which we decided to convert that to radians would be pi-thirds. And I should show my little arc there. And not only are coterminal angles the same rays, right, positive and negative, but another definition of a coterminal angle is you can go bigger than once around the circle. So I could go all the way around this circle and back up again, and I could call that alpha. And why would I want to do this? Well, when we solve equations with trig, sometimes we're going to realize that there's more than one right answer, because although this is a whole new angle, alpha is now pi-thirds plus 2 pi, because I went all the way around the circle again. Although it's a different number, it's the exact same angle. It's in the exact same position. It has the exact same 2 rays, which is the definition of a coterminal angle. And so when we solve equations, we're going to see that there are infinite answers to these equations. When we graph these equations, or when we graph these trig functions, we're going to see that they just repeat themselves over and over again because of this exact thing, because they repeat themselves. All right? Are you really going to be graphing things that go around and around and around? No, that's just silly. It kind of seems like you're trying to hypnotize someone. If you went around like 4 times, it just looks like you're trying to confuse them. But that's the idea behind it. To find coterminal angles, all you have to know is just go around the circle again. So all you have to do is add some multiple of 2 pi. So I wrote this out very mathy because that's what I like to do. But to find all coterminal angles, all you have to do is take your angle and add some multiple of 2 pi. So this just means an integer. C is like the universal notation for an integer. It's actually like a Z with like an extra little line there. Like, that's really the notation. But I don't know how to make that on my computer. But you can just say an integer, or you can just say add or subtract a multiple of 2 pi. That's a non-math way to think about it. If I added 10 pi to that angle, would that give me exactly right back where I started again? Don't draw this because it's going to get really ugly. But what if I went around the circle once, twice, 3, 4, 5? Is that right? Maybe I did too many. That's not really good circles there. But as long as I go around the whole circle, which is 2 pi radians, do you agree I'm always going to get back? So on your homework, on the next slide, it says find a coterminal angle. Here's what's kind of weird about it. In math, normally there's only one answer. When I ask you to find a coterminal answer, there are infinitely many right answers, which means if you want to really annoy me, you can add like 100 pi instead of adding 2 pi because it's still a right answer. You could add 72 pi and it's still a right answer because any multiple of 2 pi would get you back where you started. Does that make sense? Another reason that we need to know this is that sometimes they tell you you have to give a positive angle and they give you a negative angle. So you need to know to make it positive, all you got to do is add 2 pi. What if, Maddie?
So this might sound really stupid, but it's like 72 times.
Yeah, as long as it isn't, yeah, 36 times around. So that'd be a lot of circles, but yes.
Draw that.
You don't have to draw it, you just have to find the angle. Normally, I either add 2 pi or I subtract 2 pi, depending on whatever you're trying to do. But yeah, 4 pi, 6 pi, 8 pi, 10 pi. Any even number of pi would get you all the way back around. If it was in degrees, we work better in degrees because our minds understand that better. But what if it was in degrees? If theta was in like 10 degrees, what would I add to get all the way back around the circle again? 360. So the same idea, to find a coterminal angle in degrees, you can add or subtract any multiple of 360 degrees. So you could add 360 or 720, or that's about all I got. Or subtract 360.
You wouldn't add 360.
No, because you're already at 10, right? And so it's like getting back to where you started.
Oh.
So if you were at like 10 degrees, you would be there and you'd want to go all the way back around. So you take 360 plus 10. All right? So let's do one of these and then we'll go back to my other slide that I skipped.
Wait, how do you know when to add or subtract?
It's your choice. Yeah, I'll show you how I do it, but then you can do whatever you want. If it just says find a coterminal angle, you can add or subtract any multiple of 2 pi and it's a right answer. One time on my test, someone added like 10,000 pi and then put a smiley face because they knew I had to check it. Yeah. It's okay, it's fun. It means you understand the concept of it. But then I like, I'm like, because it's not not the answer I have. And I can't write down all the answers because there's an infinite number of answers. So here's how I decide what I'm going to do. Am I going to add or subtract 2 pi or 4 pi or 6 pi? It doesn't matter. But for me, I look at this and I think about, is this already bigger than 2 pi or smaller? And then that's what I do. 11 over 5, is that bigger than 2 or smaller than 2? Bigger, right? So since it's already around the circle more than once, if I was doing this, I would subtract 2 pi because I want to get it back to just inside like one revolution. Is it wrong if you add 2 pi? No. Is it wrong if you add 72 pi? No. Is it wrong if you subtract 642 pi? No. All of those are right. That's why it doesn't say find the coterminal angle. It just says find one of them. Sometimes it says find a positive and a negative, which means you might have to add and subtract, or add more than once to get to a positive one. I'm going to do this without a calculator, and then I'm going to remind you you can still use your calculator even though pi's in it. But if I was going to do this, and we want to keep our radians as fractions, we really want to keep them as improper fractions, way more like advanced math. You don't deal with mixed numbers if you don't know how to use your calculator and change your mixed number to an improper fraction, or do it without a calculator. See me and I will show you. We don't want decimals, right? If at all possible, we want to avoid decimals when we're talking about these problems, and so make sure that we're keeping them as fractions. But you would just get a common denominator here, so I need 5 on the bottom. So 2 pi is the same as 10 pi fifths, right? So then 11 fifths minus 10 fifths is just 1 pi fifths. If you hate fractions and you've never been able to do them and you're freaking out now because pi's in there, you can just do this problem without pi and then put pi back with it, right? Like on your calculator, you take on fraction button 11 fifths minus 2, and then you just stick the pi with it, and your calculator will say 1/5, and then you put the pi with it, right? So calculators are still allowed. Well, we're going to have a test with the calculator, without a calculator. On the calculator part, calculators are still allowed. You with me on that? Pi fifths. Pi fifths. One of many right answers. So that's how I decide in my head whether to add or subtract, but there's no right or wrong answer here really. But like pi thirds, in my head I say, is pi thirds bigger than 2 pi or smaller than 2 pi? Definitely smaller. So if it was me, I would say, which is actually the one that we did yesterday, I would add 2 pi. It's not wrong if you subtract it, you're just going to get a negative angle. That's okay too. Anybody want a calculator? Bill wants one just like Bill there. Here, Bill, get yours. Anyone else? Are you impressed with my drawing abilities? I can tell. You should tell me so I could this one.
There you go.
Is his room smoky today?
Did you make fun of him for that?
Yeah.
I walked in for that when he was in the massage room, and I said, hey, I heard, I just wanted to say, I said, hey, so did you set my room on fire? Nay.
Is that when he told you about the transcontinental airline?
Yeah.
Yeah.
Yeah, that's
Yeah.
not bad.
Boat says. Let's make it really quick.
right? 2 pi would be the same as 6 pi thirds, so that's what we did yesterday, 7 pi thirds. Here's a real reason for coterminal angles. When we get to solving equations, not always, but usually in the directions, it'll say solve the equation from 0 to 2 pi, which means we really like answers that are just in the circle one time. We don't like negative answers for the most part when we get to solving equations. And so that's a real reason that you need to know, how do I make a negative angle positive, but I want to be in the exact same position? I'm just going to go around the circle one more time. And so this is a really good reason of why I would add 2 pi here.
Number 2, just a fish symbol, what is that?
For, like, to go back to the previous problem.
Yeah, is it 7 pi thirds or
Fish symbol is just a symbol. It's just a symbol I use there, just like we use x sometimes, right? So in that problem I used it, but 7 pi thirds is not always alpha. Okay?
So
Alpha's like x, like theta. Yes. Theta is just a symbol. It's just an angle.
what did you put it for? You said
An angle, yeah. So on this one, I would add 2 pi, and again, you can just do negative 1/9 plus 2 pi, or that would be 18 pi, so that would be 17 pi over 9. I have at the end of these, actually, I don't know if it's printed on here or not, but yeah. It's really easy to be like, to say, oh, I don't want to deal with radians and fractions, I'll just convert everything to degrees and do it in degrees. Make sure, and I wrote that at the end of these notes here, if the problem is in radians, I want your answer in radians. So if you want to convert in between and do degrees and then convert back to radians, you can, but I really think that you should get used to dealing with radians. The exception to that would be if the problem says convert from degrees to radians, then obviously you have to change it. But in problems like this, if it's in degrees, you can leave it in degrees. If it's in radians, I want you to leave it in radians. Okay? All right. We're also going to just, on your homework today, there's some questions about complementary and supplementary angles, words that you learned back in geometry at least, if not before then. But again, we usually talk about degrees then, so we want to talk about it in terms of radians. Does anybody remember what it means if two angles are complementary? They don't just say you look nice today. 90 degrees. So normally we would say alpha plus beta equals 90 degrees, but in radians, we would say alpha plus beta equals pi halves. Or you can say 90 degrees if it's in degrees. So if they give you one angle, you just have to subtract that from 90 degrees or pi halves to find its complement. Okay? And supplementary angles are two angles that add up to 180 degrees, or in radians, that would be pi radians, or 180 degrees. So there's a couple questions on homework. We'll probably talk about one on Monday, because people always seem to struggle with it. But if they gave you one angle, you just subtract it from either pi or pi halves to find the other angle. Okay? I'm going to deal with that. All right, let's go back to the one we skipped. There are some problems on your homework that ask you to tell what quadrant the angle is in. First of all, you need to know the quadrants. And quadrant 1 is right here, and then we go counterclockwise. So this is quadrant 2, this is quadrant 3, this is quadrant 4. And yes, you need to use Roman numerals. The notation for quadrants is Roman numerals. So don't write number 3 when you should be Roman numeral 3, okay? So I'm going to do degrees first because we do better with that, and then we'll go back to radians. And we're going to, maybe I'm going to throw in a few extra ones that I normally do just so you can kind of think about the fractions as you're doing this, right? So degrees, this is pretty easy. This is 0 degrees, this is 90 degrees, this is 180 degrees, this is 180 plus 90 is 270, and then you get all the way back up to 360, and yes, you can keep going around, but one time around the circle, this would be the same as 360 degrees. 0 degrees and 360 degrees are coterminal angles because they're in the exact same position. So usually we do okay with that. If I said where is a 200 degree angle, you would say, oh, it's bigger than 180 but less than 270. 200 would be in quadrant 3, right? I feel like you're probably okay with that, right?
Would that be like a question on our test?
On your homework today. I'm going to ask you to draw some angles on your test, which is nice to know. Radians are more difficult for people because it's just new and they're fractions and it's just a combination that we struggle with. But this would also be 0 radians, right? This is pi radians. So even without having to do the conversion, think about if this is pi radians, what's halfway in between 0 and pi? Half of pi, and that's why we say pi halves.
Sounds like what, 3 pi over 6?
So if we went down to here, this is like pi plus a half pi, which some people like to say pi and a half, which is cute to say, but you really should say 3 pi. 2 pi is if we add it all the way back over to here, right? 2 pi is all the way around the circle. So this is pi plus a half, which gets me back to 2 pi all the way around. Also coterminal. So we could throw lots of things in here. I just want you to think about if I asked you to find where pi fifths were at. Think about if this is pi halves, if this is 1/2, is 1/5 bigger or smaller than 1/2? Which means pi fifths has to be over here. You with me on that? So I could say quadrant 1 without actually having to do the conversion. Is it okay if you do the conversion and do the degrees? Yes, but I just want you to start thinking about fractions. What if I said 2 pi thirds? So pi fifths, we're going to say quadrant 1. So these are here. 2 pi thirds. So 2/3 of pi. If pi is all the way around here, where is 2/3 of pi going to be? Somewhere over in here, right? Definitely in quadrant 2. Quadrant 2. So don't be scared of fractions. Like I said earlier, you might not learn trig, but I'm going to make you learn how to deal with fractions because I'm kind of forcing you to do that. That's why I don't want to use a calculator on part of this. One more. What if I said 7 pi over 6? Definitely bigger than 1, right? Yeah. It's like 1 and 1/6. So is 1 and 1/6 going to be bigger than 1/2, or is it going to be over here quadrant 3? 1 and 1/6 is going to be somewhere right here, not that far away, right? So we're going to say 3. So I just want to throw out there like the thought process that I hope maybe that you do. Okay. How about this? Just keep looking at this next before. No, I just don't even want to do it.
Same except.
Also, being able to think about what quadrant that this is going to be in, or drawing a nice angle, is another thing that I want you to start thinking about. And again, it's okay if you want to convert that to degrees first, so that you feel more comfortable with that, because that's what we're doing. I'm okay with that. I'm going to try to force you to do it with just thinking about the fraction. But on your homework, I can't stop you from doing it. I'm not going to lie. Probably most of my pre-calc class in high school, I never really learned gradients. Like, I just always converted to degrees and then went back because I thought it was stupid. But now I think it makes more sense to do this. Because so many things we do are in gradients. So when I look at 5 pi 4, step 1, think about what quadrant that's going to be in. 5 over 4, is that bigger than pi or smaller than pi? You already got it. What did you say? Quadrant 3, do you agree with that? Because this is like 1 and 1/4. Everybody with me on that? Yeah. So 1 and 1/4, if this is pi, and this is pi and a half, where would 1 and 1/4 pi be? Like way up here?
It's like in the right in the middle.
Right in the middle, because if this is half of pi, do you agree that a fourth of pi has to be right in the middle of that?
Yeah.
Am I going to be kind of leaning on that if you're a little bit one way or the other? I would be. But if you drew your line really close to one of these, I would not be leaning on that. Is that all I do to make this angle? I need to draw my initial ray. Always have to show you where you start. And I need to show which direction I'm going. 5 pi 4 is the positive angle. And since it's 5 pi 4, I would just probably write here 5 pi 4, or you could write theta, or you could do something, whatever. Theta or 5 pi 4 is probably the best option.
Will it always, like, will the initial ray always be?
Initial ray will always be at 0, because you're starting at 0 to measure.
And if it's like a negative, then the like angles are opposite.
It will go the opposite way. like number 5 here. And again, you could change that to degrees if you want. But negative 2 pi thirds means they want you to measure it in the negative direction, which means clockwise. The initial ray will still be starting at 0. But now you got to think negative, okay? So you got to go the opposite way. If I'm labeling this negatively, do you agree that this is negative pi halves now? You with me on that? Because we're going the opposite way. So it's like 0 to negative pi halves. This is negative pi, so you're going the opposite way. So your labels change. I'm not even going to label anymore. This would be negative 3 pi halves. But negative 2 thirds is smaller than negative pi. Bigger than negative pi. It's definitely going to be over here. Do you agree with that? Because 2 thirds is between 1/2 and 1. If you're not sure, change the degrees. But think about if you divided this into 3 parts, would it sort of be, I'm going to draw 2 lines here, you don't have to do that. But if I divided this whole pi into 3 parts, would that sort of be 3 equal sections? Remember the old days of fractions? And if I said, how do I even make thirds on this? Like that, right? That would, and if I shaded 2 of these in, that would be 2 thirds. Oh, remember those good days, right? It's kind of weirder on this because pi is only halfway across. But if this whole section makes up 1 pi, this would be like 1/3 pi, 2/3 pi, and all 3 would be 3/3. So I think my line should be like right there. Is that much different than that one over there? Maybe I didn't do such a good job. But it's a little bit different. It's a little bit closer to pi halves. I believe this is negative 120 degrees. If it's easier for you to think about that as opposed to 2/3 of pi. But that's what I want you to think about. Again, I'm going to be lenient on this, but I would like to think that your terminal ray is going to be closer to this axis than this axis. And I need to show the direction is negative 2 pi thirds. How do you feel about that? Not the worst thing in the world. Yeah. All this time we have. I have a worksheet for you today. I called a handout, but mostly because this is not a worksheet like we turn in the next day. It's actually from a different textbook that I feel like our textbook doesn't have the stuff that I want you to learn. So, like, my advice is treat it like a textbook page. Do it on your notebook paper. You won't turn it in until the day of the test. It's definitely, these problems are up for grabs on a homework quiz, right? You follow me on that? Like, not a worksheet due tomorrow, Monday. It's a handout that you're going to do with the rest of your chapter homework. But, again, this is my advice, and we'll kind of look at those. But this worksheet, this handout, some of the stuff is in degrees. They ask you to find the complementing degrees. Give your answer in degrees. If it's in radians to begin with, give your answer in radians. So try to get used to working with both of them as needed. So no what? No back of the book answers.
However, half of them would be done tonight.
That's what the chapter's called.
12.1 rating in the green
Okay, everyone get this. And first of all, that first 1 through 10 that says vocabulary check, that is not the numbers you're doing. So don't start up there. So see where it starts with number 7? That's not the vocab number 7. That's the number 7 on here. Yes. All right, so you can go through and circle those. Don't try to squeeze all your answers on this, right? This is from a textbook. There's not enough room. So you need to do it on another sheet of paper. I went from half my homework being done to none of it. That's nice. Yeah, I'm not laughing.
You just laughed at us a second ago.
decent amount of problems, but they shouldn't take forever to do. But it just kind of wraps things up before we start. The next section is trig. We'll start with right triangle trig, sine, cosine, tangent, SOHCAHTOA. So you can do that. So this is kind of you need to know this kind of stuff before we start doing the trig that we'll start on Monday, okay? And just think, if we don't have a snow day at all next week, we get a 3-day weekend next weekend. So let's hope for no snow day. Martin Luther King Day is the 19th. So if we make it through next week. It's supposed to be like in the 30s sometime next week. So tomorrow was really cold. I do have an assignment sheet for you finally, and it's kind of the worst joke ever to put on here after a whole debacle yesterday, but basically the joke said you're never going to do that in your life. That's why it's a joke. You'll notice there's only 3 sections on this because we are going to have 2 tests for this chapter, and so we'll have our first test after section 4.3, and we'll start 4.2 on Monday. So, but most of the joke is saying like math is never going to be useful. That's what the joke is, right? Right? Because